So section 4.3 is actually a fairly short section, and I even started the notes on the last video. So if you're wanting to hear discussion about statistically significant, you need to watch video 4.2H. I'm just going to finish this up with scope of inference. This will be the last video in chapter 4. Oop. So scope of inference is actually extremely important in the study of statistics. Maybe not quite as much in like as far as testable topics on the AP Stat test, but this is kind of how we can generalize our studies. If we do a study, an experiment, an observational study, a sample study, whatever we do, uh, who can we generalize to? What kind of conclusions can we make? So it's very important in making sensible conclusions. So the scope of inference refers to the type of inferences or conclusions that we can draw from a study. The types of inferences we can make are determined by two factors in the design of the study. So the two types of conclusions we're going to make in this class are: can we make inferences about a population? Can I generalize to a larger population? And can I prove cause and effect? Uh, and it's literally going to be, well, if you use proper sampling, then you can generalize to the population. And if you designed a good experiment and you followed the rules of good experimental design, then you can prove cause and effect. And that's it. And you can you can kind of have both. If you sample and experiment, then you'll have both. If so here's the four combinations of that are possible. So here we have where the individual is randomly selected from the population. If they were, then we can generalize to the population. So if this is yes, then we can generalize. We can generalize, right? Go across. If you do not sample from the population, then you cannot generalize to the population of interest. And that should make sense, kind of. If you don't randomly sample, if you just ask people or take volunteers, and you can't generalize to the population because you're not taking a good sample, a good representative sample. Then the second question is, okay, did you run an experiment? We could say, did we run an experiment here? The way our book words that is, they said, were the individuals randomly assigned to groups? I would kind of argue that you need more than just random assignment to groups. You need to follow all four properties of that principle, all four pillars of good experimental design. So if you run a good experiment, then you can prove causation. Okay? So if this is yes, you can prove cause and effect. If this is no, then you cannot conclude that one variable causes another. You would just be able to say that there's an association, there's a relationship between these two variables, but I don't know if this one's causing this one, right? So put those together and we got these four situations. This would be the place to be if you could choose, right? You randomly sample and then you run an experiment. You can generalize to the population and you can conclude causation. I will say though that you are rarely in this category whenever you do a study. If you're going to do an experiment and impose treatments on people, it's hard enough to get people to answer a short 30-second survey, much less call up a random person on the phone and say, yeah, you've been chosen to partake in this 2-month experiment where we're going to impose these treatments on you and do yada, 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 right? So it's very rare to be in this category, although it would be nice. So this category here, this is where we are usually for experiments. We take volunteers for our experiments. Well, if you take volunteers, you can't generalize to the population, but you can conclude cause and effect. So if you can't generalize to the population, who can you generalize to? A lot of time whenever we run an experiment, we're going to say for people like the volunteers or like the people in this experiment. So if we open up an experiment to some volunteers, we show causation, we can say, well, This variable causes this for people like the people that volunteered for this experiment. Now, the type of person that doesn't volunteer for this experiment, that person might react differently and you might not have that causal relationship between the variables, or maybe you do. Maybe those people are not any different than the people in your experiment. But to protect us from uh, saying bad conclusions, we really should say something kind of like this. So anytime I draw a conclusion for an experiment, this is going to be like the last thing I tack on to the end, and I think it's a good idea too. Usually whenever we're doing surveys, we are here. We can generalize to the population of interest. However, if we see a relationship between two variables, we really can't say causation because we didn't run an experiment. This is really the place you don't want to ever be. If you don't sample and if you don't run an experiment, then you really can't come up with many conclusions at all. I mean, it's not completely worthless. I mean, you could say, for people like the people in this study, there is an association between these two variables, but I don't know if one is causing the other, or if something, or the other is causing the one, or if there's some other variable that's causing all of it, right? So it's not a worthless place to be. It's just not a real solid statistics place to be, okay? So ask these two questions whenever they're talking about scope of inference. Example, silence is golden. Maybe you guys say that after you listen to my lectures or videos, right? No, of course you don't. Many students insist that they study better when listening to music. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address the question at your school. In each case, the response variable will be the student's GPA. So we're measuring the GPA at the end to see what happens to it. And we're probably looking at music as the explanatory variable. So yeah, so we're seeing if this has an effect on that, right? Suppose that the mean GPA for students who listened to music while studying was significantly lower than the mean GPA of students who didn't listen to music. Okay, so we got music yes, music no, and we're looking like this. And suppose our results are statistically significant. So there is a difference, a big difference, a significant difference, okay? So let's conclude that we found a significant difference in all of these examples. What can we conclude for each design? Okay, so get all the students in. So here's the study. We got all the students in the AP Stat class to participate in the study. So I just asked the kids that are in my class, ask them whether or not they study with music on, divide them into 2 groups based on their answers to this question. So I asked the kids in my class, do you study whenever you listen? Do you listen to music when you study, or do you not listen to music when you study? I put them into the 2 groups. I look at their average GPA and I see there's a significant difference. So what can I conclude? Well, did we randomly sample? No, I just conveniently asked the kids in my class. So I'm right here, right? And did I randomly assign treatments? Did I do an experiment? No, I didn't divide you in half and randomly assign music or no music. I just asked, do you listen to music? So I'm actually in this right here. I'm in that bad spot. So what kind of conclusion can I draw? I can't generalize to all JCS kids, and I can't say music causes GPA to go down. So I can't really say much of anything. Well, I could kind of say for the people in my stat class, okay, I guess here's what I could say. For kids like the kids in this stat class, there is a relation between music, and I'm going to say lower grades. I should actually just say grades or GPA. So it looks like for the kids that listen to music, the GPAs are lower and the kids, but it's not a causal relationship. I can't say music is causing your scores to go down. I wish we would say like a scores on a test instead of GPA, but whatever. Okay. Select a random sample of kids from your school. Okay, so now we're going to randomly sample. So now we can generalize, ask them whether or not they study with music on, and divide them into groups. So now I can generalize. I could say, so I can generalize to all JCS, but I can't prove causation. I don't like proof, I should say. I can't conclude causation. I don't prove anything. We just conclude. And our conclusions could be wrong. So I would say there is a relationship Well, I keep toying with this idea of whether I should say there's a relationship between music and GPA, or if I could just say that. So let me say this a different way. Listening to music is associated with lower grades for all kids at JCS upper school. So I can generalize and talk about, even though I only surveyed a small amount of kids, I could generalize to all kids, but I can just say that there is an association or a relationship between music and lower grades. I can't make the more powerful statement of saying music is causing lower grades. Okay. Number 3, get all students in the STAT class to participate in a study, randomly assign half to the music and half to no music, and then look at their grades at the end. So now I'm doing an experiment, but I'm not randomly sampling. I'm just taking kids in my STAT class. So no generalization, yes causation. So what would I say? Listening to music causes GPA to go down for kids like the kids in this study. The AP Stat kids. So I can say a very powerful statement about causation because I did an experiment. So you can say music causes GPA to go down, but you can't generalize to everybody. So this last example, we're probably going to hit both, right? We select a random sample of kids to participate. We randomly assign half of the students to listen to music. So now we're yes to generalization and we're yes to causation. So we're rarely in this spot, but if we were in this spot, we could say listening to music while studying, I'll just say listening to music causes GPAs to go down for all students. To go down, we could maybe even say on average, right? We don't want to be too powerful in our statement. On average, scores are going to go down. We probably should have said on average on all of them. To go down for all students at JCS upper school. For all JCS upper school students. To go down, let's put an on average here. Again, we're just talking about average grades. I'm not saying that there's nobody that, I'm not saying every single kid that listens to music, their grade goes down, but on average, if you listen to music, it causes your grades to go down. That's what the experiment would say. If our results were statistically significant. I actually didn't do a study, so I don't know. Okay.